So this is so far what we covered in the MongoDB. So we covered mostly the basic use of MongoDB. So we talked about NoSQL concept, and we also talked about data modeling in MongoDB. So we briefly talked about how to design documents. So document structure in MongoDB follows JSON. Basically, it's a kind of a binary representation of a JSON document. And we talked about several approaches of document structure in MongoDB. So most common approach of designing documents are embedding and referencing, and sometimes we utilize those together to come up with a hybrid approach. And also we talked about CRUD operation, create, read, update, delete documents using the query and update function and also aggregation function in MongoDB. So basically we covered all these things. Based on what we covered so far, basically you are able to utilize MongoDB. So you can create documents, you can save data, you can also use the query to retrieve information. So you can do everything in MongoDB now. So what I'm going to talk now is more of an advanced use of MongoDB. So I'm going to talk about something that might be important in the practice to kind of speed up kind of operate the query operation basically. So first of all, I'll talk about import and export database. So you have a collection in your MongoDB server, and you may have a number of documents there. So how to export that collection with the number of documents into a file, and how to import the file into your MongoDB server, something like this. And also, I'm going to talk about strategies to help you improve performance. There are two main strategies I'm going to talk. The first one is indexing. The second one is scaling. So today I'm going to talk about indexing strategy, and scaling strategy I'm going to cover it next week. So to import and export database, we can use this mongoimport tool and mongoexport tool. So basically what's happening is this. Every document in the MongoDB follows JSON structure, which is a type of JSON document. So when you export your data from your MongoDB to the file, it will be JSON file basically. So you can use that file to export to your database, and also use that file to import documents into your server. So everything will be through JSON file basically. And to utilize mongoimport and mongoexport, you have to actually install additional tools on your PC. So previously, mongoimport and mongoexport was provided from MongoDB by default, but actually from this year, they stopped that. So now you have to install additional things. So the installation is very simple. So actually I put a document on the blackboard. So if you go to the course contents, and if you scroll down, there's this file called setup mongoimport export. So you can look at this file to install mongoimport and mongoexport on your PC. So yeah, so basically, yeah, I have some information. So starting with the MongoDB 4.4, which we are using this year, MongoDB tools is not provided by default, so it should be installed separately. So how to install these documents, so you can check it. I also specified some information here. So it's very simple. So if you are using Windows, you can simply go to this link. You can just click this link on the slide, and then you can check whether every information here is correct, and you can download, and then you can install. Then that's it. So very simple. And in the future, if you want to use a mongoimport or mongoexport, you can use basically this command line on the command prompt. So you have to specify mongoimport.exe where it is stored, and then you can use this mongoimport or export. So if you're using Mac, it's also simple. In the terminal prompt, you can simply type this command: group install MongoDB database tools, and that's it. So after you install this, you can use mongoimport or mongoexport using this command. if this command doesn't work, you have to probably specify the location where it's inserted, just like what we did in the Windows practice. So I'm not using Mac, so I'm not sure exactly where it's inserted, but it should be fairly easy to find it. If you cannot find it, you can ask my TA for help. Yeah, and she'll be able to help. So that's it. So that's how you can set up and insert. So it's quite simple actually. So let's see. Okay, so that's it. Yeah, so once Mongo import and Mongo export is installed, you can use basically these two tools. So if you want to import a JSON file into your server, you can use this command. You can specify Mongo import -d. So you have to do all this in the command prompt in Windows and terminal prompt in Mac, basically. So for Mongo import, you can use a Mongo import in -d and specify the database you want to import your file into and specify -c with the collection name which you want to create, basically, and then you can specify the JSON file. So if you do that, basically the data in JSON file will be imported into collection you specify under database you specify in your MongoDB. So one thing to note is that you must have a database created first inside your MongoDB before you do importing. So the database name you specify there should be already created inside the MongoDB before you perform this command. So that's how you import JSON file into your MongoDB. So I'll skip this part to save the time, but you can do this later at your home. So you have to go through this step to do assignment 4. So make sure that you do this as soon as possible later. And if you have any problem, you can ask my TA for help. But it will be straightforward. So I put the primer dataset.json file on the Blackboard. So you can download that and you can use the Mongo import to import this JSON file into your database server, basically. So that's all. So on Windows, if you do this, basically you will see this message. The message will say that you are connected to the MongoDB server, and it will say 25,000 documents are imported successfully. So if you see that message, the import process is done successfully, basically. So you have to have 25,359 documents on your server after you import this data. And the export is this. So if you want to export your document inside your collection into JSON file, you can use this command. mongoexport -d and specify the database name, and -c specify collection name. So basically, you should have this collection and database in your MongoDB because you are exporting data. And then you can use -o and specify JSON file name which you want to create. So if you do that, data stored in collection under your database inside your MongoDB will be exported into JSON file. So here is some steps of how you can do it. You can also check them later, and you can do it later by yourself. Okay, so that was a Mongo import and export. So let's talk about indexing strategy. So indexing is this. So basic concept is this. It's a quite popular concept, not just in MongoDB, but for also in relational database, we have indexing, and also from other programming language in the data structure, we utilize indexing. So it's quite popular concept in the computer science. So imagine that you are looking for a word in a dictionary. So you have this dictionary with a lot of words inside, and you want to find a certain word. Then if you just have a dictionary like this, it's very difficult to find because you don't know where to start because there are so many words here. So you are not sure where to start. Then it will be difficult to find that word. So usually in dictionary, we have something like this. So there's an alphabet on the side of the book, A, B, C, D, something like this. So if you want to find a certain word based on the first character of your word, you can simply start from one of these pages. So it kind of helps you to scan the word much easier and faster. So that's the basic concept of index. And MongoDB also provides this indexing, so it supports the efficient execution of queries, basically. So if you don't have an index on your collection of inside the MongoDB, basically the MongoDB will perform a collection scan. It means that when you design a query on a collection, and if the collection doesn't have any index, the query will search and scan entire documents inside the collection to give you a result. So that's usually what happens. And we call that as a collection scan because MongoDB has to scan every document inside the collection. But if you create index in the MongoDB, you can limit the number of documents to be scanned because it has an index. It knows where to start. It knows where to finish. So instead of scanning entire documents, it can scan only a certain part. So the query speed will be much faster if you have an appropriate index. And in MongoDB, the index provides a special data structure. So how index will be managed and stored in MongoDB is based on this. So it will store a small portion of the collection's data set in an easy-to-scan form. So I'm going to show you more example later. But basically, it will store the value of a specified field, and it will be sorted by that value. So index will keep sorted a list of a certain value you specify to index. So this is a simple example of indexing, basically. So let's just say that we have multiple documents. So here on the figure, you can see that there is a data page. So data page is a list of documents. So let's just say that in our collection in MongoDB, we have a list of documents like this. And let's just say that you chose a certain field from the document. So let's just say that you chose the like the age field. So let's just say that each document represents a user information, and you want to search a certain user based on their age, based on how old they are. Then you may use the age field to make an index. So if you use the age field to make an index, basically index will be like this on the top here. So index will keep only two things. The index the field, which is the age, so number is there, 4, 7, 8, 16, something like that. And it will also keep the data location on the disk. So when you have data, the data is stored on your hard disk drive or solid disk drive. Basically, it's stored on physical disk drive. And index will keep the location of that document in your disk drive. So when you find a certain index, you are able to locate to that position in the disk as soon as possible. So that's the basic concept of index, basically. And also, one thing you have to know is that when you create an index will be sorted. So that it's easy to find a certain document based on age in this case. So let me tell you why being sorted is important in the index. So basically, the main concept is this. When you have an index and when it is sorted, it's much faster to find a certain information. So we can compare the speed between the case when we don't have index and when we have index in this case. So let's assume that we don't have any index and we want to find a certain document with the age 16, for example. So I said score 16, but let's assume that we want to find a certain user whose age is 16. Then if you don't have an index, basically we have to scan all the user documents in the collection. So we have to go through a collection and we have to look at each document and we have to check whether this person's age is 16 or not. So we have to scan all the documents in a collection. And if we assume that we have an n number of users, then the total document we need to scan will be n basically, because we have to scan everything. So that's when we don't have index. And if we have a simple index like this, as shown below here, and we keep age information and we keep this index sorted, then we don't need to scan all the documents actually. So we simply scan until we have the age bigger than 16. So for example, in this case, we look at the first document and the age is 4, lower than 16. So we go to next document and we go until we find the age 16 on the 21st position. So on the 21st document, we find that the age is 16. So we retrieve that information and we show that to the user. And we go to the next document, 22nd, it's also 16. So we show that document. And then we go to 23rd. And let's say the 23rd, the age is bigger than 16. Then we stop there. We don't need to scan anymore because the list is sorted based on age. So on average, the number of documents to scan when we have this index will be simply less than n. So we can save some time. So this is basically advantage of using index. So you can perform the query and find the information much faster. So that was a very simple example I presented to show how the index can speed up the process. And however, in the real world, actually index is more powerful. So you don't need to know the detail about B3, but I just want to show why it's more powerful than what I showed earlier. So B3 is actually one of the data structure which is utilized in computer science. And when you make an index in MongoDB and also in other applications, in many cases, they use B3 data structure to make information sorted. If you use B3 structure, it's much faster actually. So let's look at this example. So in the earlier example here, when we have a list and when it's sorted in a linear way like this, to find all the documents with the number 16, it took 22 scans because they were in the 21st and 22nd position. However, if we have all the documents sorted based on the B3 structure, it's much faster. So first, we look at, so basically, if you have B3 structure, it starts from the top node. So on the top node, the first number is 40. So 40 is bigger than 16, so we move to the next left node. And on left, there is number 10. So 10 is bigger than 16. So we check the next number, and next number is 30. So 30 is lower than 16. So 16 is between 10 and 30. So we go to the middle, and on the bottom middle node, the first number is 10, bigger than lower than 16. So we go to the next one, and then we have 16. So we retrieve that document, and we go to the next one. It's also 16. So we retrieve that document. And then there's no more information there, so we stop there. So in this case, basically we only need to scan 6 documents to find all the documents with the 16. So it's much faster. And on average, if you use a B3 structure to make an index, basically the query, when you design a query, it only needs to scan log n number of documents. So much faster than earlier cases. So that's the main advantage of using indexing in MongoDB basically. So here are simple characteristics of the indexing in MongoDB. So in MongoDB, we use a B3 structure to keep index. And also, the index in MongoDB is actually very similar to the relational database. So in the relational database part, I didn't talk much about indexing, but also in the relational database, you can utilize indexing in a similar way. And if you use it, it will improve the performance significantly. So how to create an index in MongoDB? Basically, you can utilize this create index function. So you can specify DB, the collection name, which you want to create an index, and then you can use the create index function. And here you can specify the field you want to use to create index, and you can specify the number 1 or -1. So that's how you want to sort. If you specify 1, index will be sorted based on ascending order. If you specify -1, it will be sorted based on descending order. So that's the main way to create an index, basically. And here is some speed comparison. So if you import the JSON file, which I uploaded on the Blackboard, you can create the restaurant collection, basically. So each document of that JSON file contains restaurant information. And then in this case, I simply used that collection to do some query. So I designed the aggregation query, which is sort all the documents based on the borough. So borough is like a neighborhood of the restaurant. So here I simply compare the speed in the case where I didn't use index and when I used the index. So when I perform this query, if I create an index based on the borough first, and if I perform the query, basically the speed of this query will be 10 times faster. So that's what I wanted to show you. So with an appropriate index, basically the speed of the query will be much faster. And when you design an index, when you create an index in MongoDB, you can create a single index. So single index is basically an index on a single field. You can also create compound index. So compound index is an index of multiple fields. When you specify multiple fields in index, now you will have a hierarchy, basically. So in the second example here on the bottom, we have a user ID 1 and score -1 to create index. If you do that, basically user ID will be the first hierarchy in the index, and the score will be the second hierarchy in the index. So what it means is that the index will be sorted based on the user ID first. And some documents will have the same user ID. And for that groups, it will be sorted again based on the score, like that. So there will be hierarchy of the sorting order, basically. So how to make a compound index? It's very simple. So you can use the create index function again. And here you can specify field 1, first hierarchy, and field 2, second hierarchy, like this. So in the example here, basically I make an index based on borough and cuisine. So borough is the neighborhood of the restaurant. So I sorted based on the neighborhood first. And then cuisine is what kind of a food they serve, whether they serve Chinese food, American food, or yeah, something like that. So again, yeah, there's a speed comparison. So you can try that by yourself and to see how fast the query can be performed when you have index, basically. And this part is about this. So when you have an index, depending on how you design your query, the index might be utilized or not. So if the index is utilized, your query will be performed fast because there is index and index is utilized. However, you create an index, but if you design a query in a wrong way, sometimes the index may not be utilized. Then your query will be slow because it's not using index. So for example, let's assume that you created an index based on this function on the top. Then in the restaurant collection, you are making a compound index based on the first hierarchy of borough and second hierarchy of cuisine. So you can create that index. And then you may design a query which find restaurants in the Brooklyn area and serving American food. So you want to find the restaurants in the Brooklyn area and those restaurants who are serving American food, then you may design this query. So you can use the find function and borrow, you specify Brooklyn, and choosing, you specify American like this. And if you use that query, it will utilize the index. So if you want to know whether your query will utilize the index or not, at the end of the query, you can simply add this explain function. So if you add that explain function at the end of your query, then it will provide you more information about how your query is performed. So you can see these results if you try. And here under input stage, there is a stage field. So stage field will specify whether index is used or collection scan is used. So in this case, on the stage field, it says IX scan. That means index scan is used. So basically, because you made index borrow choosing, and you are using borrow and choosing in your query, then index is utilized. So your query will be performed fast. So this is what this explain function is talking to you. Also, another example here. So when you have so earlier we made a compound index. First hierarchy was borrow, second hierarchy was choosing. And if you make a query that utilizes only first hierarchy, it will still use index. Because the first hierarchy was borrow, and you design a query which use borrow. So it will utilize that information and it will use index. So if you design that query and if you add that explain function, it will tell you that index scan is actually used and your query performance will be faster. So the point is this. When you have an index, as long as the query follows a hierarchy in the index scan will be used and your query will be performed fast. So that's the main thing. So this is when your index will not be used. So again, first hierarchy was borrow, second hierarchy was choosing. However, if you just make a query which utilizes choosing only, it's not utilizing index because first hierarchy is borrow, so that should be used first in your query to make use of index. The second example, same, we are using choosing and borrow. So choosing is used first and borrow is used next. In that case, index will not be used because when we designed the index earlier, we used the borrow as the first hierarchy, but that order doesn't match with what we designed in the index. So the key point here is this. When you have a compound index, there is a hierarchy, and your query should follow that hierarchy to utilize index. Okay, so that was the main concept. So, and there are other more special type of index in MongoDB. One is a geolocation index. Basically, if you have GPS information or longitude, latitude information on your data, then you are able to use this geolocation index. So it supports efficient calling of geolocation coordinate data. So in the future, if you are utilizing location data, geolocation index might be kind of a good index you may consider to create. And once you have a geolocation index, you can also do distance calling. So you can try to search whether one, basically if you want to search documents which are in a certain neighborhood, not that far from 100 kilometers or something, you can do that using geolocation index basically. So more information is here on this link. So you can search more this later if you need to utilize it. Another type of index which is used quite often in the real world is a text index. So text index supports efficient searching for string content in a collection. So basically, when you have a text field in your document, and if you use the text index, you are able to do text searching simply by using MongoDB function. So this is really powerful because usually when you design an application and when you design an online service, to provide the search functionality, sometimes you have to design that functionality by yourself. You have to actually make a code and you have to make the functionality to provide the search option to the user. However, in MongoDB, there is text index. So if you simply make a text index, MongoDB will provide search functionality by default through the index. So this is actually really powerful and it can save a lot of time when you develop application in the real world. So if you make a text index based on the text field in MongoDB, basically it will ignore stop words like the, a, or. Those common words will be ignored in the search, and also many like different types of words will be stamped. So if you have a playful, plain, place inside the text field, then those will be stamped into play like a main form, and it can help a user to search much better basically. The more detailed information is again on the link, and here I put some example based on the text index. So basically it's something like this. If you want to create a text index, you can use a create index function again, and you can specify the text field, basically the field that contains the text information, and then you can specify text with a double quote. Then that field will be considered as a text index. And let's say that you have a multiple fields in your document which contain text information, and you want to provide the search functionality for all the text fields you have in a document. Then you can simply specify something like that. With a double quote, you can put $** and text. Then all the text fields inside your document will be indexed, basically. And in the future, if you want to provide the search functionality in the query, you can design something like this. So in the query, in the MongoDB query, using find function, you can use the text operator and you can use the search operator to search something. So let's say that let's say that in the restaurant collection, which we which you can create from the JSON file, which I uploaded on the Blackboard, then you can simply use the create index option to make the text field, text index, and then you can use the text operator, search operator, and you can type Flatbush. Then all the restaurants that has that contains name Flatbush or that is located near like a Flatbush area will be searched basically. So by using this, you can do text query, which is a search operation based on a text. So this is really powerful. Again, instead of developing your own search functionality by coding it, you can simply use this query, just one line of code. Then search functionality will be performed in the MongoDB. So basically that's all about the index. So I briefly talked about it, and I briefly explained how you can utilize it. So in the future, in the real world, when you need to make your query performance to be much faster, then you can utilize it. So what I'm going to talk about here is the one of the design issue in the indexing strategy. So the general rule is this. If you use index, it will improve performance. So index is a good thing. It can improve the performance of your system. However, if you misuse index or if you abuse index, actually it can slow down performance. So you have to think about this very carefully. So some people think like this. Index will increase the performance. So I have multiple fields in my document. So in my MongoDB, I have a document and I have a lot of fields. Because index will increase performance, some people may think that, oh, then maybe I can just make an index for every field, something like that. So I make an index for a certain borough field, choosing field, name field, restaurant ID, address. For every field, you may create index, and you may think that it may improve the performance because I create an index for every field. However, there is a problem for that. So index is good to improve the performance, but if you have too many index, actually it slows down the performance. So there's a trade-off. So you have to think about this very carefully. So actually, this kind of mistakes happen quite a lot in the real world. So I captured this screenshot from one of the like a computer science community, and this guy was working as an IT consultant. So he was going to different company, and he tries to optimize the process of the company, and he also examines the problem and try to fix it if the customer asks for it. So he shared his story about this. So he said that, so if I go through it together, basically, he said that recently he helped the customer to optimize his database. And when he examined the customer's database, there was a write drop, and that was running consistently at 95%. So basically, the CPU was spiking constantly and making for a poor experience. And he looked at index. So he was examining many different things. He wanted to find out why this is happening. And when he looked at index, he found that the customer had too many index. The customer created 126 index on his database. And he also found that there were 24 index created for us one collection, basically. So he said that for each insert update, basically for each insert, MongoDB was having to insert the document and update 24 index. So that was the cause of excessive write drop. So what this means is this. Earlier, I said that when you create an index will keep a certain field of document sorted. So index will always have information sorted. So whenever you add a new data, whenever you update a document, index has to be updated together. Let's say that we have a document. So earlier we had a user document, and each user has an age. So one person's age was 16, and next year we updated that information into 17 or something. Then the index has to be updated again, because if a certain information changes, the sorting order might be changed too. So index should be updated and sorted again. So that costs time. So in this case, the customer had 24 index on one collection. So if one document in that collection is updated, or if someone add one document into that collection, these 24 index should be updated together. So that costs time in this case, because this customer had too many index. Whenever there is an update, whenever there is an insert, that slows down the performance, because all these indexes should be updated together. So that's one thing you have to be careful. So index will increase query performance in terms of reading and sorting operation. However, whenever there is an insert or update operation, it will cost, because indexes should be updated together. So that's why too many index is actually not good, because it will make the system to spend too much time on updating and inserting, which is less important actually. So yeah, that's one thing you can take from this real world case, basically. So basically, to make an appropriate index, you have to understand what kind of a query will be performed in your application. So you have to think about what kind of a query will be performed a lot in your application, and what kind of operation your user will try to request a lot. Based on that, you have to create index. So you have to understand which operation will be performed a lot, and you have to try to save the time for that. So when you have a MongoDB query, you have to think about what criteria will be used in the matching operator. And based on that, you design index. then then you'll be able to speed up the performance of your application. Also, you have to limit the number of indexes in a collection. So too many indexes is not good. And also the last point is this: you have to ensure that index will fit in the lab. So sometimes let's say that you have a certain document in MongoDB, and certain field may have a very long or large information. In that case, if you make an index based on that field, then the index size will be big, basically. So if you simply make an index based on the number field, the index size will be small. But if you make an index based on like a really long description, then the size of index will be big. The problem is this: if your index is too big, then it may not fit in your RAM memory inside the computer. If index exceeds the size of RAM, what's happening in the system is swapping, basically. So those data, so for the index, those data that exceeds the size of RAM has to be stored inside hard disk drive. And then only some part of index will be stored in the RAM. So RAM is basically the memory we utilize, the CPU is utilizing directly. And if some part is stored, if some part doesn't fit in the RAM, it will be stored in the hard disk drive. So later, if we need that information, we have to retrieve that information into the RAM, and some of the other information on the RAM should be saved back into the hard disk drive. So we call that as a swapping in computer science. And if that happens, it actually slows down the process because swapping takes a lot of time. So that's the last point. So when you design an index, you have to ensure that index will fit in the RAM.